right in front of you. Today I'd like to read through each of the directions and actually go through each of the problems with you so you know what a chapter test looks like, and then help you with each of the different sections in the test because there's different portions that we're going to take a look at. In the first section, you can see that we have multiple choice. For whatever reason, when I put this on the copier, some of these questions through our multiple choice section on page 2 kind of looked a little distorted, as you can tell, but I can still kind of talk you through what I'm expecting you to answer for the questions on that second page. On the third page, you have this section called Understanding Concepts, in which we're going to apply what we learned through our study of bar graphs, line graphs, and circle graphs to take some of that data, turn it into a percentage, and then create a circle graph angle and actually make the circle graph itself. If you're following along with this video, that'll make it a lot easier for you to actually take on that challenge. Lastly, it's again applying concepts, in which we're going to look at the different ways in which you would round or take different types of measurements, put those in order from least to greatest, and actually look at which one would be more precise. So let's get started. Testing concepts. Number 1. In the blank at the left, write the letter of the term that best describes each statement or answer the question. Number 1. A pitcher holds 1 meters. The difference between those two temperatures is 273 degrees. So if you added 273 to that, you'd be given your actual measurement. Looks like 18 plus 273 would be. A scale is marked in tenths of a kilogram. To what precision can the mass of a bag of apples be measured? A is correct. Number 5. Which of the following is not a measurement? Age, shoe size, weight, or prescription, where these actually have a number that is associated with them. 6. Which multiplier would you use to convert 1.9 kilometers to 0.9 or smaller, because kilometers is actually bigger than meters? I would multiply that by 1,000 and use letter A here to turn that in. Kilometers, meters, centimeters, or light years. Now, light years is between weight and mass. One of those is going to stay the same no matter where you are, where the other is a reflection of the gravitational pull. And if you're on Earth and then you're on Mars, your gravity might be different. So which one of these makes the most sense? I'm thinking letter C, because your weight would change based on the gravity and your mass would remain the same. Number 9. A digital thermometer shows the temperature as 21.2 degrees Celsius. The thermometer is precise to the nearest, so 21.2. It's got to be to the nearest thousand, or the decimal place right here. So I would have that as letter C. Number 10. A baseball is pitched at 148 kilometers per hour. Which term describes this measurement? A scale, a base unit, volume, or a rate. One measurement could be compared to another, and one of those measurements is in time, so we'd say D, rate. In grams, volume, capacity, mass, or weight. Grams is our measurement for mass, our base SI unit. 12. A section of a circle graph measures 180 degrees. Which percentage of a circle graph is in this section? 18, 50, 80%, or 100%? Now remember, a circle has 360 degrees, so to find this out, you would take 180 and divide it by 360 to come up with what that percentage would be. 180 out of 360 is going to give you B, 50%. Number 13. What unit would you use to measure the area of a carpet? Meters, square meters, cubic centimeters, or square kilometers? You might think centimeters, but cubic centimeters is actually the volume. Here where you're measuring area, you only need 2 measurements, so it's going to be squared. Square meters or square kilometers between those two. Probably makes the most sense that square meters, just because kilometers are really, really big. Letter B would be precise. All right, for this section, you're going to have to listen more than watch, because this page copied this way for whatever reason, but I'd still like to help you out with it. Number 14. It says, which graph would be best to show the percent of your class wearing glasses? A bar graph, a circle graph, a line graph, or D, any of these graphs? Well, we're trying to show a percentage, so that's part of the whole. circle graph is going to be our best bet. I'd say letter B. 15. Data in the table is organized in A from greatest to least, B to the greatest precision, C in rows and columns, or D all of these. I think C is our best answer, rows and columns, right here. Number 16. What unit would you use to measure the length of a carpet? Meters, kilometers, kilograms, liters. I'm going to pick A, meters. 17. Which is a reasonable estimate of the length around your wrist? A, 8 millimeters, really, really small. B, 20 centimeters. Okay, we might have to come back to that one. C, 36 kilometers, way too big. And D, 58 nanometers, even smaller. B was the only one that made sense by process of elimination. 18. Which is the symbol of the SI unit of temperature? Temperature, you might want to say, well, that's going to be T. It's not. Oh, it could be K for Kelvin, but Kelvin doesn't have this degree symbol next to it, so it's going to throw you off. And it's not Fahrenheit because that's our standard customary system. It's actually letter A, just a plain old K for Kelvin. 19. How do you calculate the angle to show 20% in circle graph? This might be helpful for the next part of our test where we actually have to calculate the angle for a circle graph. If you remember from our lesson, we take whatever degree measurement we have as a fraction, turn that into a decimal and multiply by 360, or as a fraction multiply by 360. In this case, you're going to take 0.20 times 360 because you turn 20%, move the decimal to 0.2. 0.2 times 360 is going to give you that degree measurement. Number 20. Which is not an SI unit? Kilograms, decimeters, ounces, and millimeters. Meters, liters, and grams are our base units. Ounce is a measure of volume, but that is not a base unit for what we would calculate in the SI system. Alright, bear with me for 21, 22, 23, 24, 25, and 26. Numbers 21, 22, 23, it says list 3 measurements and 3 other facts that describe this container. I'm going to ask you, well, what is the width of the top of the container, what is the height of the container, and what is the mass of the container? Those 3 numbers that are right here are the 3 measurements that could go on these 3 lines. Those are describing this can. The other ways in which you would describe this can is to maybe say, well, what other information is there? What color is it? What shape is it? What is in the can based on the label right here? You would list those things on these lines here. I'm flipping the page into the next section, Understanding Concepts. Here we're following along is going to be really, really careful. I wish I could write on the screen, but I won't be able to, but I will point with my arrow to the part where I'm asking you to write in these specific areas to then help you create what it's asking us to do. The directions say the table shows the age and sex of 60 house sparrows. Find the percent of the total of each of the sparrows. Then complete the table by finding angles you can use to draw a circle graph. So we got to find the percentage. Now to find a percentage, you have to know the total of all 4 of these items. So let's add them up. 15 and 15 is 30, 18 and 12 is 30, 30 and 30 is 60. So all of these are out of 60. What I would do with my pencil if I'm taking this test is draw a line right here and say 15 out of 60, 12 out of 60, 18 over 60, and 15 over 60. Now I have 4 fractions. To turn those into a percentage, I just simply divide. What is 15 divided by 60? As a percentage. What is 12 divided by 60 as a percentage? 18 divided by 60 as a percentage. 15 divided by 60 as a percentage. Now in this case, you're going to get 15 divided by 60 is going to give you a decimal. The decimal is going to be 0.25. Then you're going to take that 0.25, multiply by 100, move the decimal 2 places to the right. This would be 25%. Well, if this one's 25% because it's 15, this one's 25%. 12 divided by 60 is going to give you 0.2. 0.2 times 100 is going to move that decimal. This is going to be 20%. 18 divided by 6 is going to be 0.3. Move that decimal. This is going to be 30%. So again, 25, 20, 30, 25. Now how do you get to that circle graph angle? Remember to this question here that asks us about how we turn that percentage into the circle graph. We turn that back into a decimal. We just multiply by 360. The other way in which we learned how to do it is if you had it in fraction form, you could compare it to something over 360 and then find that value as if it was a fraction. In this case, we can simply multiply, turn this back into a decimal as in 0.25, times 360, what does that give you? 0.25 times 360, same for this bottom one, what does that give you? 0.2 times 360, what does that give you? And 0.3 times 360, what does that give you? Let's go back and do the math, and maybe you've got your calculator now to be able to do that. 0.25 times 360 is going to give you 90. That's going to turn into our degree measurement. So a 90-degree angle. We all know what that looks like. 0.20 times 360 is 72 degrees in this section right here. 0.30 times 360 is 108 degrees right here. 0.25 again is 90. So I've got a 90-degree angle, a 90-degree angle, a 72-degree angle, acute, and 108, an obtuse angle. Now, there's one line that's drawn in here already. What I would do to make the estimation or to sketch these lines would be to draw a straight line from this corner to this corner across here and turn this into the two 90-degree angles that I have. So this is a straight line right across here. That's going to create a 90-degree angle here and a 90-degree angle here. And now I need to create one line that is a 72 and a 108-degree angle. Now if this line went straight across here, that's 90. So if I'm a little bit short and I go this way, that's probably about a 72-degree angle there. And then it creates the opposite, the complementary angle, the 108-degree angle on this side. I draw this line somewhere right in here, and I'd have 90, 90, 108, 72, and I'd have those appropriately labeled with their degree measurements. Okay? Number 6, suppose you want to graph the number of each type of sparrow. What kind of graph would you use? Well, the number of each type of sparrow would take you into what we would call categorizing these things. So you'd have the sparrows as your big category, the type of sparrow would be the smaller individual category. You're still comparing that to a number. So whenever you're comparing two variables and one of those variables has multiple types or multiple categories, you're going to probably best use a bar graph to describe that. I'd write that right here. In the last section, we're applying concepts that we've learned. Number 1, it says explain how you would round 2.625 meters to the nearest tenth of a meter. So here's our tenths value, this 6. I'm going to circle that 6. I'm going to look to the right. And this 2 tells that 6 to stay exactly the same. So this is going to be 2.6. Nice work. Number 2, how many centimeter cubes can be shipped in this box? Well, centimeter cubes would have to be 1 centimeter by 1 centimeter by 1 centimeter. So we're going to have to find the volume of this, and then we'll be able to answer that question. To find volume, you're going to multiply length times width times height. So 20 times 20 times 10. 20 times 20 is going to be 400 times 10 is going to give you 4,000 centimeters cubed. If they were individual 1 centimeter by 1 centimeter blocks, there would be 4,000 that fit into this box. Number 3, list these masses in order from greatest to least. Remember, from greatest to least. It might be helpful to look at our SI unit figure to say what was the top of that SI scale, or our stair-step method, what was the largest of those units. Kilo was the largest, so kilo is going to go first. I'd write 9 kilograms first. Next I have grams and milligrams. I know grams are larger, so I'm going to pick 422 next. And between 6,471 and 76, obviously 6,471 is bigger. So 1, 2, 3, 4. Those are in order from greatest to least. Number 4, compare the precision of these rulers and list them from most precise to least precise. What I'd like you to do is to write just the letter of the ruler on this line with a little comma in between. So from the most precise to least precise. Most precise would mean that which one has the smallest units of measurement. Here's centimeters, centimeters, and millimeters. Millimeters is going to be smaller. And I should say this is half centimeters, where this is full centimeters. So still millimeters is smaller, so letter B goes first. Next you have letter A because it's half centimeters. And then last you'd have C, so this would be B, A, C. In the final portion of our assessment, we have sometimes essay questions where you're describing your learning or describing your knowledge. Answer the following questions using complete sentences. Number 1, how could you estimate a cat's length if you did not have a ruler? Are there other ways in which you could measure or something else you could use to compare that measurement? That's what you would describe here. Number 2, Jenny says she can identify an SI unit base because a base unit does not contain a prefix. Is she right? I would probably say no, because meters, liters, and grams, yes, don't contain prefixes, but actually the base unit for grams is actually kilogram, and that has a prefix in it. So Mr. Shane gave you that one. Hopefully that helps. I don't want students to get confused and all of a sudden get something wrong on the test that they should have that knowledge or that mastery of. Sometimes they ask a little bit of a tricky question. So hopefully that helps. That takes us through our assessment. If you watch this video and followed along, you should do pretty well on what would be the first of the tests that we've taken. God's blessings. Thanks for watching.